Hello everyone. So in this video we are going to learn how to prepare benzene diazonium salt. That is nothing but in short form we remember this as a BDS or BDC, benzene diazonium salt. So for preparation of this we must remember these 5 points. So this compound BDS, that is benzene diazonium salt, is stable only at short interval of time, and also at low temperature it is stable. Third point, BDS is readily dissolved in water and it decomposes easily in dry state. Fourth point, BDS is colorless crystalline solid that we have to use immediately after preparing. So these 5 points we have to remember whenever we are preparing BDS. So first point, it is stable only at short interval of time and even at low temperature, and it readily get dissolves in water and decomposes in dry state. Fourth point, BDS is nothing but a colorless crystalline solid that we have to use immediately after it is getting prepared. So while preparing BDS, the reagent we have to use, and that is nothing but NaNO2, that is sodium nitrite. With that we have to use dilute HCl, or if it is not given, then we have to we will be getting HNO2, that is nothing but nitrous acid. With this will be also getting a cold medium, or sometimes they may give 0 to 5 degrees Celsius or 273 Kelvin to 278 Kelvin. Now we'll see how this BDS look like. So we'll take aniline. So we all know like what is the structure of aniline. So in above benzene we'll give NH2. So this is nothing but your aniline, primary aromatic amine. In this will pass what? NaNO2 in dilute HCl. With this will pass temperature as what? Cold medium or 0 to 5 degrees Celsius or 273 Kelvin to 278 Kelvin. Now what we'll get? We'll get BDS. This is nothing but benzene diazonium salt. How it looks like? So, N triple bond and X or Cl. For now just keep Cl because we are passing HCl, and here we'll get plus. This is nothing but your PDC, or we can say BDS, benzene diazonium salt, or we can say benzene diazonium salt of chlorine. That's why I have written this BDC. In IUPAC will get this as a arene diazonium salt. So this is nothing but your what? This is we are looking for. This is nothing but your BDS or BDC. Just remember BDS in short, so that we'll have that useness of how to remember. Now we'll see mechanism how to create this BDS. So we are using NaNO2 plus dilute HCl. So NaNO2, that is nothing but sodium nitrite with dilute HCl, 2 molecule of dilute HCl. This will give nitrous acid, right? With this we'll get NaCl. Now this nitrous acid will react with aniline. So how it will work? And double bond O, I am just drawing the structure of nitrous acid. This is nothing but your HNO2, right? And we'll have the lone pair here. Now what will happen in the presence of H plus that we are passing from dilute HCl? What it will get protonated. So where this H plus attack at this oxygen, right? So this H plus attack at this oxygen to form a hydronium ion, H and double bond O, and the positive charge on O's because the valence is getting increased. Now we'll heat so that we can remove the water molecule to get electrophile. So while heating, this bond will get break and will get minus H2O, that is nothing but water molecule. With this will also getting what? Electrophile plus H2O molecule. So now this is your electrophile. We in short we use E plus, or we can write electrophile. Now this electrophile will attack on what? Aniline. Got it? So here we have lone pair on NH2, right? Aniline. This is nothing but what? Aniline, right? Here what will attack? Nitrous, that electrophile. So where it will attack, we all know we have lone pair on nitrous, so it will directly attack to N, right? So what we'll get? We'll get one intermediate N H H. With this we'll get one N double bond O. Get it? At the same times, when remove water from this, from where? We'll remove these two hydrogen. At the same time we'll remove this oxygen. So we are breaking two bonds here and we are breaking two bonds here. So how many bonds we'll get? We'll get three bonds here, right? Because we are breaking two sigma bonds. At the same time we are breaking this N and oxygen bond also. So we will be doing this in presence of what? Dilute HCl. So what we'll get? We'll get benzene diazonium salt. So how it looks like? N triple bond, and we have broken these two bonds. At the same time we have broken these two bonds. So these two positive negative from here, at the same time two positive from here, will create two pi bonds between N and N. At the same time this because we are increasing the valency of nitrogen, so we'll have positive charge on nitrogen. At the same time of here we'll have Cl attached with this nitrogen as a minus. So this is nothing but your BDC or BDS, benzene diazonium salt, right? With this what we get? We'll get water, because we have broken these two bonds. At the same time we are breaking this water molecule. So this H2 and this oxygen will remove as a water molecule. Now what we have to remember, important points. This aniline is what? Aniline was primary aromatic amine. So BDC or BDS we can only prepare for whom? Primary aromatic compound or amine. Get it? This reaction is nothing but diazotization reaction that we discussed above. This reaction is diazotization reaction. Diazotization means what? We'll get N triple bond N bond. So just remember, in short, if there is something like N between N and N, we are getting some bond. So this is nothing but diazotization reaction, right? So I told you previously, BDC is stable at only what? Stable at low temperature, right? Because we the N2, this N2 we are getting here. So because N2 is strong leaving group, the one who can leave the compound. Strong leaving group, or we can say N2 is a strong leaving group, or just remember, at high temperature N2 will leave. That's why I'm saying BDC is stable only at low temperature. If we'll increase temperature, the BDC will not get formed, means N2 will get evolved. So what will happen? N2 gas will evolve. One more thing. So BDC or diazotization reaction is for what? Primary aromatic aniline or amine. Primary aromatic amine.